Hi, this is Andrew. Thanks for joining me. This is the 7th video in the Python series. I think I've set it up now. If you haven't seen the earlier ones, take a look if you want to. So now we're at 7, where we're talking about functions. And functions are blocks of code designed to do one specific job. And really, the idea is you create a function to do something, and then anytime you need to do it in your program, or later on, you can say, I'm going to use this function again. So it can save lines of code. It can also make things easier to read. It can prevent errors. All kinds of uses in there, and it prevents you needing to reinvent the wheel every time you do something. So here's how we're going to get started with it. First thing, when we have a function, the first line in the function is going to be a keyword defining the function, followed by, or the keyword def, which defines a function, followed by the name of the function. What are we going to call it? Then a set of parentheses, then we'll have a colon. And that set of parentheses we'll come back to later on. That's kind of important. Then we have a docstring in triple quotes. It describes what the function does. Then our body is indented one level, and that's our function. That's what we do. So to call the function, we just type the name of the function followed by the set of parentheses. Calculate batting average. That's our function. So here is an example. We have that keyword that I talked about, the name of the function, the parentheses, the colon. Here's the docstring, display a simple greeting, and we're going to print that greeting is going to be hello. Now, obviously, this is an overly simplistic case where you could do this a lot easier by not using a function. But we want to make sure our functions work and we can do things. So def greet user, and then we're going to do 3 display a simple greeting. And as you'll see later on, we can do more with this than just display a simple greeting. This is what we're going to do here. That simple greeting is just print, and we'll say hello, and that's done. And now we get to the next part of our program. We're going to run our greet user function. And when we run it, we get hello. Pretty simple, pretty straightforward, but we have our answer there. And we could be doing all kinds of things in the function. So we'll see that as we move forward. Now, let's say instead of greet user, we have greet user. We want to pass some information to the function. We want to say whatever is in the parentheses later on is going to be username. And then we're going to display a simple greeting. And instead of hello, it's going to be hello. And we'll add the username dot title. If you remember, that is capitalizing the first letter of the username. And then we'll do, just to make it fancy, plus quote space. No, we don't want a space between username and the parentheses, or in the exclamation point. So now we're going to greet user, and we're going to send it 3 different commands. We're going to do Jesse greet user Fred, and greet user Bill. And you can see I'm typing lowercase in all of them. And hello Jesse, hello Fred, hello Bill. They're uppercase. This does exactly what we want, and everything is working the way we expect. We're passing passing a name into the function. The function says print, and then hello, username, title, the whole deal. So says for now, let's make one. We already did, but let's do one that's kind of a lab. This is a lab in the middle. We have a lot more after this. So what we're going to do is create a script with a function that will convert Fahrenheit to Celsius and display the number. So we're going to call the function 5 times, giving it different temperature values each time. So we're going to pause for a second, let you think about that, and come back to it. And we're back, and we're going to start by defining our function. So I will cheat a little bit and say we're going to define, we're going Fahrenheit to Celsius. F2C is our function name. And in here we're going to have degrees F. And this will change to convert Fahrenheit to Celsius. And here now, instead of printing hello, we're gonna just get rid of this, and we're gonna say we need to do a calculation. So what is our calculation going to be? It's going to be, we'll just call it degrees C equals degrees F minus 32. Same math rules as always. We'll put that in parentheses. We'll put 5 divided by 9 in parentheses, and then we're going to run the script. And before we do need to print out our results. So I'll tab over and print and say str of degrees F plus quote degrees Fahrenheit is close quote plus str degrees C and plus and a quote and do in Celsius. And if I haven't missed anything, we should be able to now call a function as many times as we want with different numbers. So I'm going to call a function degrees, F2C. And we need to pass our value in there. We're going to start with 32. We know what that is. F2C 70. F2C do 100, and let's add in 50 in there, just F2C 50, and then of course we also need to test F2C 212. So if I run this and I did everything right, 32 degrees is 0, 50 is 10, 70 is 21, 100 is 37, and 212 is 100. So I have this function I can reuse, I can recall as many times as I want, I can do this calculation on it. What we'll see in future chapters is I can actually not even have this as part of my script. I can put it someplace else and just call it in when I need it. So it really can be super valuable that way. So let's, this is the example that I came up with when I was doing this, and it looks a lot like what I did here. F2C. I could have I could define C2F. I could create a menu to say is your temperature in Fahrenheit or Celsius, and to figure out which function to call. So I can do all of this in this conversion process. I can have conversions of Fahrenheit to Celsius. I can have conversions of miles to kilometers. I can have all of these functions built to do all of these conversions and figure out which one I need as I'm going, depending on what the user needs in the program. So there's my example, and that looks a lot like what I did there. Now, there are situations where we might have multiple variables, and this is an example I used when I created these slides a few years ago, and in all honesty, it would take me some some thought and investigation to figure out exactly what the numbers are and how to make the calculations. But I have a slightly more complex calculation here of the force of gravity. So based on the mass of the two objects and the radius or the distance from them, the force is gravitational constant times mass divided by r squared. So, and with that we can figure out the gravity in newtons. That's great. Ultimately, it's a long calculation with a whole lot going on, and I don't quite understand all of it or much of it, or years ago maybe. But all we have to worry about is we're calling a function and passing 3 variables to it. To simplify things, let's look at an easier calculation. So instead of doing Fahrenheit to Celsius, let's say with 2 variables, what's a common thing that has 2 variables? Area. Let's say we have length and width, and that's what I'm defining, and I'm going to say calculate the area of a rectangle. And then it's pretty simple. Area equals LEN, length times width. And then I'll print area. The area of the rectangle is, quote, and I'll do a little bit simpler of a area. So area of rectangle there. Now I can call that function. In this case, I'm printing. What am I doing? That print is not right. I'm going to call. I had a different. This slide is wrong because I initially did it slightly different. I don't think I had a print statement there. I'm going to call the area function, and I'm going to do 3, 4, and I'll call area 5, 9. So when I run that, the area of the rectangle is 12. The area is 45. 3 times 4 is 12. 5 times 9 is 45. So we have a functional function, or a useful function there. Now, what if we wanted to figure out what's in the box, at least from a volume perspective? We want to figure out what the volume of a box is. We can do this, where we have really no different from what we did here. Instead of area, we're going to do box volume and length, width, and height. So instead of area of rectangle, the volume inside of a box. And so volume is length times width times height. And then I can change this to the volume of the box is, and turn the area there. Kind of cheating, just deleting and recreating, but that's a common thing where you have useful code and you just copy and paste and modify. You can easily make a lot of mistakes there, so be careful. But for the sake of keeping the video from going too long, that's what I'm doing here. And if I didn't mess anything up, of course I did. the function is not called area, it is called box volume. Like I said, when you copy it and do this kind of thing, it's very easy to make this kind of mistake. Some development environments will be a little bit more aggressive about preventing you from doing something stupid. This one is not as aggressive, so it let me run it and just said, here's your error. So now we might have default sizes. So if we might deal mostly with pizza boxes that are 1 inch tall. So in this case, we can say height is equals 1, and that's going to be default value. We can still pass it other values. So we still have 3, 4, 5. We have 3, 4, but we can do 5, 5, 7. We can do 18, 18, 1. Box volume 18, 18, and that'll be 1 because I'm not putting the height there. And when I run this, I have 3, 4, and the 1 is 12, 5, 5, 7 is 175, 18 times 18 is 324, and I went backwards. So there we go. We have our volume. Now, sometimes here we've been printing out our results. What if we don't want to print out the results? What if we want to use the results in the rest of the program? So let's say we want to calculate how many M&Ms you can store in the box. And you have a box and you say it is 3 inches by 4 inches by 1 inch, and we want to figure out 40 M&Ms fit a square inch, so how many M&Ms will fit in the box. So let's do that. We can say we still have our box volume, length times width times height, volume inside of a box, everything's the same until we get to here. We're not printing out what we got, we're returning that. Return V. So what happens when we return V? Instead, we have a variable here that we're going to create. So now our variable is volume, and now this is volume from the original, from the calling script, from the original script. And what happens is we say volume equals box volume, that's our function name, with us passing 3, 4, 5. So what happens is whatever value is calculated by this function is passed back into this variable. This doesn't have to be called volume, it can be called whatever we want. It could be called X, it can be called anything. But this is a variable here that gets the result of this function when we send these values into it. So now we're really like, we just want to know a volume. We don't want to know how it was done. We don't want to know anything about it. And we could actually, go further with it and say we just want to feed the length, width, height, and figure out how many M&Ms are in the box. If that was what our function needed, or we could have another function that calculates value of M&Ms. In this case, we're just going to do M&M equals volume of the box, which is in this case volume, and we're going to multiply that by 40 because it's square inches and 40 M&Ms fit in a square inch. And then we can print out the results there. And we do print, you can fit that tells us how many M&Ms we can fit, and then we're saying M, and I have no affiliation with M&Ms. It's possible the example came from the book. I don't remember right now, but I do like M&Ms, so there we go. And I can say the volume of the box is 3, 4, 5. I can fit 2,400 M&Ms in the box. Now, if I were to call this with 111, I would expect the answer to be 40. And I get the answer of 40. If I'm calculating this, I might say well, 3 times 4 times 5. It's pretty straightforward. 1, 2, 1. That gives us 80. So I might experiment a little bit to make sure I'm not making a mistake on my math. But once I have it right, the numbers that I put in, I'll trust reasonably well. So now, one more thing. It's useful and it's based on stuff we've previously done. We're going to make a menu. And if you remember last time, we have the elif that we can use. So we're going to use this function right here. And we're going to let the user decide what they want to put in the box. I'm going to cheat no, I'll wipe all this out and start over. So we can retype it. Print. What do you want to put in the box? And now our options we're going to give, and we're creating a menu, we're just a display. Now we're looking for input, but first we have to have a few lines of description of saying, if you want this, do this. If you want this, do this. And we're going to start with, we're going to say 1. So if they select 1, they're selecting M&Ms. Close quote. And there are things I could do right here. I could do a new line. I could do other things, but I'm gonna do it this way. Print, and this is gonna be 2. I guess marbles are a little bit bigger than M&Ms, and then print 3. And we're going to say that is what's in the box. Gwyneth Paltrow's head. And then we can say, let's muscle memory sometimes when I start typing AN, I type Andrew. Answer equals input. Choose a number. And then we have results for all of them. But ultimately, we might want to do something else other than just if answer equals, and remember it comes in as a string, so we have to compare it to a string. 1 will print, this is where I'll probably cheat next time. Just giving you a heads up. I like M&Ms. Ooh, that was kind of prophetic that I left the 7 there. Not intentional. If you don't know, that's what option 3 is all about. elif answer equals 2. Print, and we'll do this feels like marbles. And then the third one is answer is equal to 3, and print the Wrath of Brad Pitt. And that gives you another hint if you don't know what that is. So, else, now the thing is, what if someone types 4 or something completely different? I'm just going to go with print you chose poorly. And let it go at that. So now if I run this program, I created a menu. What do you want to put in the box? I'll do 1. I like M&Ms. And of course, I look at it and I say, ooh, I don't like I want to put a colon and a space there. So I will save that, run it again, and this time I'll select 2, and now I like if this feels like marbles, and then I'll do one more just for, or actually two more. I hit enter twice and it gave you chose poorly. Oops. So I meant to hit 3, and that's The Wrath of Brad Pitt. And this time I'm going to choose something else. Like I said, I hit enter before. I choose 8 and it says you chose poorly. So it's a menu that's working. So why do I care about a menu? Because let's say create a function to calculate the volume of a box. We'd already done that and I deleted it. Use a menu to decide what's in the box. There's our 3 options. For each answer, call the volume function and calculate how many of each item will fit in the box. We can make our own values. So we have 40 M&Ms per cubic inch. We can say that that marbles take 20 marbles per cubic inch, and then we got to get some weird calculation for Gwyneth Paltrow's head. It's been a long time since I've seen the movie, but I would assume like a 12 inch by 12 inch by 12 inch box. So that is, we can do the calculation and do one head will fit in the box that size. So we do fractions of a head, and it's already getting more disturbing than we needed. So let's get started on figuring this out. If we go back, and I'll cheat this way since we're already running a little bit long. Here's my calculation. Here's my function that I want. I'm going to create the function again and put it up here. And I'm going to do def box volume, and I'll length, width, height. It's pretty clear, and so I don't need to spell them out. Now here I'll do the volume of a box. And then I'll V equals L times W times H, and I'm going to return V. Now if I go into each of these, if answer equals 1, I'm going to say items. This is really M&Ms, but I'll say items equals V times 40. Print. Instead I'm going to say you can fit I do plus, and I do a string of items, and then I'll add that to M&Ms in the box. Ooh, too many there. Now with 2, I will do, yes, I did items. So I called, I didn't do this right. I was thinking ahead. So create a function, calculate a volume of the box, use a menu. So I need to define the size of the box. So I need another line here. Volume equals. Actually, I will call this. I don't want to. I'll do volume just for clarity's sake, and this is what it's going to be here. Volume equals box volume, and I need to put numbers in here. I'm trying to decide. I could do user input, but I'm going to do 12, 12, 12, just to not have a whole bunch more input, be able to test my cases a little bit easier. Volume equals box volume 12 times 12 times 12 times 12. Items equals volume, which is this variable, which is this function and I could have done directly here, I could have done box volume 12, 12, 12 times 40. Maybe I'll do that on the next line and you'll see exactly what it looks like. So in this case, I'm going to do items equals box volume, and I'm calling it with 12, 12, 12, and then I'm going to multiply that by 20. So now I'm going to copy this, I'm going to put it here, and I'm going to say marbles, and this is something I feel like I have to fix. And actually in the third one, I'm going to instead of doing a calculation, because again I don't want to do fractions of the head can fit in a box, I'm just going to say you can fit one head in the box, because I don't want to call a function there. It's cheating a little bit. So that's what I have there. M&Ms. You can fit 69,120 M&Ms in the box, and I would expect that number will be half for the next one, because I will run the same thing. I'll choose marbles. 65,000, that looks like about half, or 34,000, 69,000. And then of course I'm going to try the third option just for completeness, and you can fit one head in the box. If I were having the user input, I might change that, and didn't want to get any more morbid than I already am. For the record, it's a movie. It's not something that came out of my head. It's someone else's. So, and then of course, let's do 7. You chose poorly, and anything else I would choose poorly. So there are functions. We called a function here. We could have called another function that said volume equals box volume, and then the next one would have been items equals, and we could have had a function for items that allowed you to select what kind of item you're putting in there, or you can use functions to do anything. I can say I could use a function to calculate area, I could use a function to calculate squares, or any kind of calculation that I want to do, any kind of thing I want to do. I could have the function, each time it's called, add to a list and allow the program to repeat until I tell it to stop. And really, it might seem simplistic to say, what is the area of a rectangle? That's just length times width. But what if I wanted to say, call a function again and again and again, and each time you call it, it adds the item, it appends the answer to a list, and then when we get to the end, I now can add up all of those items in the list and say, this is the area of an irregularly shaped piece of something, where I did each separate rectangle as a separate item and added them all together. So a lot of different ways to use functions. This is the key piece. We define it, and then we pass whatever variables to it, and we can either have do something with it and display something, or return the value. And in order to actually use that value, you say, I'm going to call this function with these variables, as I did here, and I'm going to have the result of that function return into my variable called volume. So that V gets returned into this volume variable, and this variable could be named anything. This could be named red bag, or whatever we want, and whatever we're defining, and that's the volume of that item. So that's all I have for you today. Thanks for watching.